Now we discuss about the secret of alpha decay, which is a tale of atomic courage. Imagine an atom as a bustling city, its nucleus the very heart of its existence, a crowded core where protons and neutrons coexist under the immense forces. But sometimes this nucleus becomes too heavy, burdened by an excess of protons and neutrons. And what happens when something becomes unstable? And it basically transforms. And this is the story of alpha decay, which is a process where an atom sheds its extra weight in the form of an alpha particle, the tale of courage at the atomic level. In the atomic world, the alpha particle, which is a combination of two protons and two neutrons, is like a miniature superhero, a tiny fragment of the nucleus ready to break free. But escape is not that easy. Now imagine being trapped inside the deep well, surrounded by towering walls of the nuclear force. The alpha particle does not have enough energy to jump over the barrier, and yet it escapes. But how it escapes? This is where quantum tunneling comes into picture, a bizarre yet powerful quantum phenomena that allows the alpha particle to slip through almost like a ghost passing through a wall. For years, physicists were puzzled. How does an alpha particle escape if it does not have enough energy? Then enters George Gamow in 1920s. Gamow proposed that instead of thinking of the alpha particle as a solid object, we should think of it as a wave. And we know that in quantum mechanics, waves can exist both sides of a barrier. This idea led to a revolutionary insight. The probability of tunneling determines how quickly an atom decays. Some elements decay in seconds, others take billions of years, and all because of this tiny probability. The nucleus is basically a battlefield of two competing forces: the strong nuclear force, which is a short range but powerful force that holds the neutrons and protons together, and the Coulomb force, which is a repulsive force pushing the positively charged protons apart. In smaller nuclei, the strong force basically wins. But as the nuclei grow larger, like the nuclei of uranium or nuclei of thorium, the repulsive Coulomb force starts dominating. And that is when alpha decay becomes nature's way of restoring the balance. But why should we care about the alpha decay beyond physics? That is more important. And this is because it is a driving for innovation for a sustainable future. The alpha decay plays a role in nuclear chain reactions that provide clean and the carbon free energy. The alpha decay or the alpha particles emitted in radioactive decay are used in radioisotope thermoelectric generators, which are used in space missions and remote locations for sustainable power. Also, the targeted alpha therapy TAT uses the alpha emitting isotopes like astatine 211 to kill the cancer cells with extreme precision. In medicine, the alpha decay produces essential isotopes for diagnostics as well as for treatment. And the alpha decay also helps in tracking environmental radiation for safety, utilizing radiation sensors. The soil and rock studies are also used in geological research to understand the pollution and resource management. On the other hand, using the radioactive dating, the alpha decay helps the date the rocks. fossils, and ancient artifacts, which is used to reveal the Earth's history. The thorium based reactors utilize the isotopes which are undergoing alpha decay, which is a promising, safer, and more efficient nuclear energy. Nuclear waste solutions need the understanding of the alpha decay that helps in designing the better disposal systems. Now, the question arises, what happens after the alpha decay? Or what happens after the alpha particle escapes out of the nucleus? Now, once the alpha particle escapes, what happens the next? The parent atom, now relieved of its excess burden, transforms into a different element. For example, uranium 238, when it emits an alpha particle, it gets transformed into thorium 234. This process, as already mentioned, reduces the atomic number by 2 units and mass number by 4 units. A nuclear identity shifts in action. Alpha decay is also considered as a cosmic clock. Alpha decay is not just about energy, it is basically a cosmic timekeeper. Scientists are using uranium 238 to date the age of Earth as well. Carbon 14, which is a radioactive element, helps archaeologists uncover the timeline of ancient civilizations. And geologists study the decay chains to map out the Earth's evolution over billions of years. The power of alpha decay helps to build a sustainable future. From powering the spacecrafts to treating diseases and unveiling the Earth's past, alpha decay is more with the global sustainability goals contributing to a better healthcare, clean energy, responsible consumption. So it's not just like a natural process, it is a cornerstone of human progress. Now, again, another question arises that why alpha decay is so special. So, alpha decay is not just a random decay, it's nature's way of keeping the balance. It's a perfect demonstration of how quantum mechanics, nuclear forces, and cosmic evolution all intertwine. From the tiniest atomic escape to the vastness of the universe, alpha decay reminds us of the hidden forces shaping the reality. So, next time you hear about nuclear physics, remember it is not just a science, it is the key to our sustainable future. Finally, if you found this fascinating story to be interesting, don't forget to like, share, and subscribe for more deep dives into the wonders of nuclear physics. And let me know if in the comments what do you think is the most exciting application of the alpha decay. Thank you so much.